CS 3351 Digital Principles and Computer Organization. Topic is Instruction Execution, presented by Devi Visalaksha, Assistant Professor of CAC Department, Rohini College of Engineering and Technology. Processor. Instruction Execution. The instruction execution is a processor can be split up into number of stages. How many stages there are on the purpose of each stage is different for each processor design. Examples include two stages and 3 stages. In 2 stages is having instruction fetch and instruction execute, and the 3 stages instruction fetch, instruction decode and instruction execute. The MIPS processor has 5 stages. The instruction fetch stage fetches the next instruction from memory using the address IF in the program counter register and stores this instruction in the instruction register. The instruction decode stage decodes the instruction in the instruction register, calculate the next PC ID and reads any operands required from the register file. The execute stage executes the instruction. In fact, all ALU operations are done in AX this stage. The memory access stage performs any memory access required by the current MA instruction. So for loads, it would load an operand from memories. For stores, it would store an operand into memory. For all the instructions, it would be nothing. For instruction that have a result, the write back writes the WB result back to the write file. Note that this includes nearly all instructions except VNOPS and stores. Basics MIP implementation. MIP implementation includes the subset of core MIPS instruction set, the memory reference instruction, load word and store word, the arithmetic logical instruction add, sub, and, or, and SLT, the instruction branch, equal, and jump, which we add last. This subset does not include all the integer instructions, nor does it include any floating point instructions. An overview of the implementation. The core MIPS instruction includes the integer arithmetic logical instructions, the memory reference instructions, and the branch instruction. For every instruction, the first 2 steps are identical. Send the program counter to the memory that contains the code and fetch the instruction from that memory. Read 1 or 2 registers using fields of the instruction to select the registers to read. For the load word instructions, we need to read only 1 register, but most other instructions require reading 2 registers. For example, all the instructions classes except jump use the arithmetic logical unit after reading the registers. The memory reference instructions use the ALU for an address calculation, the arithmetic logical instructions for the operation execution, and branches for comparison. A memory reference instructions will need to access the memory either to read data for a load or write data for a store. An arithmetical, logical, and load instruction must write the data from the ALU or memory back into the register. Lastly, for a branch instruction, we may need to change the next instruction address based on the comparison. Otherwise, the PC should incremented by 4 to get the address of the next instruction. A logic element need to be added that chooses from among the multiple sources and steers one of those sources to its destination. This selection is commonly done with a device called a multiplexer.